Good morning, students. I am Manikant Mishra, Modern English School, New Area. Hope you all are fine. So, in the last part of the video, we have already started the modern classification of an element. So, once again, what is a modern periodic law? The physical and chemical properties of an element. The physical and chemical properties of an element are the periodic function of their atomic number. The physical and chemical properties of an element are the periodic function of their atomic number. As we have last time discussed that this mostly discovered the atomic number, and he said the atomic number is a more fundamental than atomic mass of an element. Based on this, when the elements are arranged on the basis of increasing atomic number, then we found that all the demerit which were found in the Mendel's periodic classification of an element are disappear. That's why it has understood that atomic number is really decides or depends the fundamental properties of an element rather than atomic mass. So based on the modern periodic table has formulated, that is the physical and chemical properties of an element are the periodic function of their atomic number. When we say atomic number, it means number of proton presence in the nucleus of an atom. Atomic number, the number of proton presence in the nucleus of an atom. And the number of proton presence in an atom is also equal to the number of electron. And as we know that the electron is not present at one particular place in an atom, rather it is distributed in a various cell. This distribution of electron in a various cell is nothing but it is called electronic configuration. So, it will not wrong to speak the present basis of classification or the modern classification of element is the basis of electronic configuration. So, electronic configuration is the basis of the classification of an element in the modern periodic table. So based on that, elements are arranged successfully. Not only that he arranged successfully, all the demerits which were found in the Mendel's periodic table are also disappear. Now let us discuss about the modern periodic table. My dear student, first of all, in a modern periodic table there are 18 groups. There are 18 groups, as we have already discussed. Vertical columns are called group. This is called vertical columns are called group. All these are group. Okay. So how many groups are there? 18 groups in the periodic table. Vertical columns are called group and Horizontal rows are called period. Horizontal rows are called period. These are period. Horizontal rows are called period and vertical columns are called group. So there are 18 groups and 7 periods in the modern periodic table. There are 18 groups and 7 periods in the modern periodic table. Now, if you have the idea about the electronic configuration based on orbital, I mean to say S, P, D and F. If you don't have, then it is not problematic. It is not a problematic and the question do not arise in the board exam or in your school exam based on this. But I am trying to just give you the idea about it. The modern periodic table basically divided into 4 blocks. The S, P, D and F. If the electron goes into the valence, if the last electron goes into the S orbital, if the last electron goes into the S orbital, then it is the element belongs to S block element. If the valence electron or last electron goes into the S block element, then it is called S block element. As for example, suppose we have sodium 11. So if you write 1s2 2s2 2 3s1 2 plus 2 4 4 plus 6 10 plus 1. You see the last electron, it goes into the S orbital. So it means sodium belongs to S block element. Sodium belongs to S block element. Similarly, if you talk about like aluminum 13, so 1s2 2s2 2p6 3s2 3p1 2 plus 2 4 4 plus 6 10 10 plus 2 12 plus 1 13 is the atomic number of aluminum. So where the last electron goes? In a p orbital. So the aluminum belongs to p block element. Similarly, if you go for the scandium 21, scandium 31, so 1s2 2s2 2p6 3s2 3p6 4s2 3d1. So last electron where it goes? In a d orbital. So the scandium belongs to d block element. So similarly there is a f block element. So whole periodic table is divided into 4 blocks: S, P, D and F block. Group 1 and group 2. Group 1 and group 2 belongs to S block element. Group 1 and Group 1 and 2 belongs to S block element. Group 1 and 2 1 and 2 belongs to S block element. Group 3 to 12, group 3 to 12 belongs to D block element. D block element. Group 13 to 18, group 13 to 18, P block element. P block elements. Though we do not consider that 18th group, but they also belongs to P block element. While talking, we only talk 13 to 17. As you know that the 18th group is a inert gas element. But last electron goes to P block. Based on that, I am discussing with you that they belong to P block elements. Now, at the bottom of the periodic table, at the bottom of the periodic table, in a modern period, I am discussing about the modern periodic table. At the bottom of the periodic table, there are two rows. There are two rows, each containing 14 elements. Each containing 14 elements. Each containing 14 elements belongs to F block element. F block element. So basically, this periodic table has been divided into 4 blocks: S, P, D, and F. Group 1 and 2, S block element. Group 3 to 12, D block element. Group 13 to 18, P block element. And at the bottom of the periodic table, there are two rows, each containing 14 elements, belongs F block element. My dear student, now this is another very important information. This left side of the periodic table, generally metals are lying. Left side of the periodic table are generally metals are found, and right side of the periodic table, lying non-metal. Now these metals and non-metals are separated by zigzag line, and the separated elements are called as a semi-metals. As I said, left side of the periodic table, metals are lying, whereas on the other hand, right side of the periodic table, non-metals are existing. These metals and non-metals are separated by zigzag line, and those elements which differentiate between metal and non-metal, that is called semi-metal, like silicon, germanium, tellurium. These are the elements called semi-metal or metalloid. Silicon, germanium, tellurium, these elements are called semi-metal or metalloid. Now next, very much informative, like group 1 element is called alkali metal group. Group 1 is called like a sodium, potassium, rubidium, cesium, francesium. In a group 1, The elements are lithium, sodium, potassium, rubidium, cesium, francium. These elements belongs to group 1, and the common name of group 1 is, or general name is called alkali metal group. Now second group, beryllium, magnesium, calcium, strontium, barium, radium. Beryllium, magnesium, calcium, strontium, barium, radium. This group belongs to group 2 element. These are called alkaline earth metal. These group are called alkaline earth metal. Group 17, fluorine, chlorine, bromine, iodine, astatine. Fluorine, chlorine, bromine, iodine, astatine are belongs to group 17 called halogen. Called halogen. Many times we have discussed why it is called halogen, because these elements when react with the metal form salt. That's why it is called halogen. Halo means salt, gen means producer. These elements have capacity or properties when they react with metal forms salt. So commonly it is called halogen. Fluorine, chlorine, bromine, iodine, astatine are called halogen. And the group 17 is known as halogen. Group 17 is known as halogen. And group 18, helium, neon, argon, krypton, xenon and radon are called zero group element or inert gas. Zero group because it has a valency 0, because at ordinary condition they do not take part in a chemical reaction, they do not take part in the bond formation. That's they have zero valency. That's why it is called zero group element, or also it is also called inert gas elements. Inert gas element. Now when group 1 and group 2 combine with either group 15, 16 or 17, when group 1 or group 2 combine with group 15, group 16 or group 17, they form ionic compound. Group 1, group 2, when they combine with 15, 16, 17, they form ionic compound. Even group 13, when they react with 15, 16, 17, they also form ionic compound. But when group 15, group 16, 17, when they combine, they form a covalent compound. Even group 15, 16, group 15, 17 combine, they also form covalent compound. So these are very important information, my dear student. Once again I am discussing with you. Just recap it. Group 1, group 2 combined with 15, 16, 17 elements, they form ionic compound. When group 13 combined with 15, 16, 17, they form ionic compound. But when group 14 combine itself, group 15, group 16, group 17, if they combine, then they form covalent compound. If group 15 combined with group 16 or group 14 combined with 15, group 14 combined with 16, group 14 combined with 17, then they form covalent compound. Like as for example, group 1 sodium combined with 17 chlorine NaCl forms ionic compound sodium chloride. Similarly, group 2 magnesium combined with group 16 element oxygen forms magnesium oxide, that is also covalent compound. Group 13 aluminium combined with 17 chlorine forms AlCl3, which is also ionic compound. Similarly, if you go for 14 carbon combined forms covalent compound. Carbon combined with groups chlorine, group 14 combined with group 17 forms like a CCl4 carbon tetrachloride, which is covalent in nature. Group 16 like a sulfur combines with oxygen forms sulfur dioxide, which is also of covalent compound. Group 17 Cl combined with Cl, Br combined with Br forms Br2 or Cl2, which is a covalent compound. So watch the video carefully, honestly, and if there is any kind of doubt, please let me know. Thank you. Have a nice day.